Okay, it looks like everything is good to go here. I'm going to go ahead and get started. So today, I'm going to be giving you a demonstration of how assisted modeling works and how it can really enable the business analyst and the citizen data scientist to take their analysis one step further with machine learning. So we're going to take a look at a data set today that is from a telecom company. I'm going to place an input data tool onto the canvas, and let's go ahead and get that churn data set into Designer. So what this data set is it contains a bunch of information about customers that are using a telecom product. You can see here that we have the customer ID, the gender, if they're a senior citizen, many fields, device protection, tech support, whether or not they stream TV, and ultimately, this historical data set indicates whether or not that customer has churned. Suppose that you are working at a telecom company and you want to be able to make predictions to figure out if your customer is going to churn or not churn based on all this information. It turns out assisted modeling is a great resource to do this, and this enables us to make a predictive model, and it helps us understand every step of creating that model very easily. So let's go ahead and get started. I'm going to attach the assisted modeling tool to the input data. To get this started, I have to run the workflow, so all of that data makes it into the assisted modeling tool. Now we're all set and ready to go. Let's go ahead and start assisted modeling and get that model created. So just like Melissa said here in her presentation, we're going to start here by giving an introduction as what the users, what you are going to be going through as you do the assisted modeling experience. So this is the tutorial page where you can see what steps you're about to experience. The first step we have selecting the target variable. And I'd like to add also, I'm not going to dig too deep here because we're going to be hitting every single one of these steps. After that, though, we're going to be data typing and figuring out what kind of data we're dealing with for each column in that churn data set. Next, we're going to clean up that data set to make sure it's nice and clean and ready to go into that machine learning model for training. After that, we're going to be selecting the columns that we want to use for the machine learning model, which ones are important and which ones aren't important to make that model as best as we can possibly make it. And finally, assisted modeling is going to do the really fun part where we can select which type of machine learning model. Today is going to be classification. And we can compare these models side by side and figure out which one works best for us. So let's go ahead and get started. Okay, target variable selection. So what we are doing here is we have a churn data set, and we want to know, based on all the information in that data set, whether or not that customer is going to churn. So in this available target variables, we have every single column name here, but we want to know as the target, as the prediction, whether or not that customer is going to churn. So let's go ahead and pick churn here for our target variable. This brings up another window here where we can select which type of model we want to use. As Melissa explained, today we're going to be doing classification, which is available in beta. Not available in beta is regression. So here, let's go ahead and figure out, well, first, let me explain what a classification problem is. Classification says, hey, what am I predicting? What kind of thing am I getting out of this? And for the churn, if you look in that data set, it's did I churn or did I not churn? And today we are interested if the customer has churned. So let's go ahead and pick this yes as a class of interest. I'd also like to note here that if you don't quite understand what the target variable is, there's plenty of information going through this where you can really understand what classification means with some examples. You can also understand what the class of interest is by hovering over this tooltip to get a quick explanation. We're really enabling that citizen data scientist or business analyst to get insights and understand how this model is exactly working. So we'll pick churn and go ahead and go to the next step here, which is data typing. I'd also like to add here that once you select this target variable, you're locked in, and this is what you're going to be using for this assisted modeling tool. If you want to switch things up, you can go and you can put another assisted modeling tool down onto the canvas. Okay, data typing. So what we're doing here is assisted modeling has gone through and inspected your data set. And we have made recommendations on what the type of data we believe each column to be. So you can see here we've got all of our column names again here in this data set, and it made a recommendation or a suggestion as to what type of data that should be. So if we're looking here, if I click on total charges, you can see that has been assigned numeric. And over on the right here in the column details, we have data type probabilities. So we can say with high certainty that this column is likely going to be a numeric value. But suppose that there was another column where we weren't quite sure what the data type was. We can go through and we can actually make a change over what assisted modeling has recommended. So suppose that you know tenure, for example, is supposed to be an ID instead of numeric. Assisted modeling gives you that capability to really own your model and make that change yourself, so you have the results and the information that you want for this model creation. Also note here, when I use ID, this is actually going to drop that value from the machine learning model because we can't use those when we're building a machine learning model. I'm going to go ahead and change this back to a numeric because I like the recommendations that assisted modeling gave me. If we continue to go through here, you'll see the rest of the columns, and all of them have been assigned a data type based on what we believe that data type to be. Suppose, though, that you do not quite understand what exactly is going on here. What is a numeric? What's a category? What's an ID? Assisted modeling gives users the capability to go through and get educated as they're building these models and read these definitions of what an ID is, what a category is, and many, many more. So this is really an informative educational experience when we're building these models. Okay, so now I've set all of my data types and I'm happy. Let's go ahead and go to the next step here, cleaning up the data set. A machine learning model really likes a nice, clean data set when you go to train that model, and this step is accomplishing that. So what assisted modeling has done, it has gone through each of your columns in the data set, and it's figured out where there's values missing. This step allows you to go in and fix those empty spots with an appropriate method. So here, assisted modeling has recommended that total charges, the missing values, be replaced with the median. And let's talk about what assisted modeling is doing behind the scenes here. You can see off to the right that there is a decision tree talking about how assisted modeling has made the decision to take total charges and replace all of the missing values with the median. Let's go through that really quick. In the decision tree, it says, is there more than 80% of that data missing in the total charges column? The answer is no here. Is it a categorical? Again, the answer is no. And this is how we got to the conclusion of replacing missing values with median. Again, though, it's important to note that we empower the users of assisted modeling to choose which method they want to use if replace with median isn't the right answer. So if you know that you need to go in here and drop that column, replace with the mean, replace the median or the mode, we give you that option to go in and manually make those changes. Again, for completeness, it's also important to note, suppose I don't know what median is. I don't know what the mean is. Over here on the right, we have very verbose explanations of each of these methods explaining to you what exactly is going on with your data set when you choose these methods. I'm happy with replace with median for total charges, just like assisted modeling recommended to me. So let's go ahead and move on to the next step, which is selecting which columns we want to use for that machine learning model. Again, we have all of the columns here selected from this data set, and we're doing some really cool things here in assisted modeling. This step tells you which of these columns really is powerful in predicting, in our case, whether or not a customer is going to churn. So you can see here that total charges, tenure, payment method, contract, all have good predictive power, and assisted modeling has recommended to the user that they use those for their model. Suppose, however, that there was a column where the predictive power was really low. It turns out in this data set there is one. If we look at phone service here, assisted modeling is telling you that the predictive power for phone service isn't really powerful when you're trying to predict whether or not a customer is churned. Because of that, we have automatically deselected that column. Again, if you click around here, you can see off to the right, we have a distribution of each one of these columns. So for total charges, we can see what kind of data is in that column. I'm really happy with the columns that Assisted Modeling has selected for me, and you can see that these have all been recommended by this green checkbox here. So I'm going to go ahead and leave everything how it is. Again, if I want a little bit more information about what that predictive power actually means, off to the right here, we have a Glossary tab that can explain to you what is exactly going on and what this predictive power means and how should I make a decision for which columns I want to use in this model. So this is all really great. I'm going to keep those selected, and now we're going to do the really fun part. We're going to go through and figure out which machine learning model we want to choose to figure out whether or not a customer has churned or not. Okay, this is the really fun part. So here, for classification, Assisted Modeling gives you several choices for choosing which algorithm, which model you want to use and which ones you want to train when we're making these predictions. So here, we give the citizen data scientists, we give the business analysts all kinds of information about what is going on with each one of these models. So you can see here, we have logistic regression, random forest, and decision tree. And we can make comparisons between all three of these models. We can look at the accuracy, interpretability, and speed. So suppose that I want a model that I can easily interpret and explain to my peers when I'm making these predictions. Based on this picture here, it looks like logistic regression and decision tree are the two that you might consider. However, maybe you're really interested in the accuracy. It turns out that the random forest is a really accurate model, and this might be the one that you're interested in. Because we have time here, though, and I'm really interested to see how each one of these perform, I'm going to select all three of them, and we're going to compare them side by side in the leaderboard to figure out which one did the best. Again, for completeness, off to the right here, we are explaining all these terms that are on the screen that might be confusing. So this is really educating you on how these models are working and what these terms mean. So we've got accuracy, interpretability, and speed. So like I said, let's go ahead and get started. I'm going to leave all three of these selected, and we're going to train these models. So as we're training, if you wanted more information about the logistic regression, the random forest, the decision tree, you can go in here and look and read all the information we provided you on pros and cons for each model, the definition of what's going on behind the scenes with these models, and also some use cases so you can really dig down and figure out which model makes sense for what you are trying to solve. As you can see here, we are ready to go. The models have completed training, and we have percentages there at the top that are indicating the accuracy of each model. We can see here that logistic regression has about 80.3%. So we're going to look at these side by side, but let's go ahead and dig down one step deeper and see exactly how logistic regression did. So like I said, logistic regression had an 80.3% accuracy. What does that mean? You can see here we have some tooltips to explain what exactly is going on for accuracy and balanced accuracy. Let's go ahead and talk about these a little bit. So for accuracy, this is how many predictions were correct over the total number of predictions, which is how we got 80.3%. Suppose, however, though, you want to go one step deeper and you want to see how each of the levels in the column or the class did. So here, we have two options in our predictor. We have yes, they churned, or no, they didn't churn. So if we are just concerned with yes, we can say, of the ones that were supposed to be correct, or yes, how many of those were correct and how many were incorrect? And for the class no, they were supposed to be no, how many were correctly identified as no versus how many were incorrectly identified? Now what we can do is we can go through and actually look at these models side by side in the comparison tab. So it's a lot of the same information here that we just talked about with logistic regression, accuracy, balanced accuracy, but we can also see the random forest and the decision tree as well. We also have some new metrics in here, such as log loss and area under the curve, which are explained nicely here off to the right in the Glossary tab. So if I don't know what the area under the curve is, I can go read a definition to really get a good feel as to what I'm looking at so I can make an informed decision as to which model I want to use. We also have the Roc Curve, which is the receiver operating characteristics. And it might be a little bit small on your screen. However, we've got two axes here, the false positive rate and the true positive rate. And we can go through and say for a given false positive rate, what is the true positive rate for that specific model? And this can help you make an informed decision as to which model you want to use. So since the logistic regression performed the best in terms of accuracy for us, let's go ahead and use that model and get it down onto the designer canvas. Here, you can see that we have a logistic regression pipeline. This is the picture that shows what you're about to get on the designer canvas. We've got data typing, missing values, column selection, one-hot encoding, which we can talk about, logistic regression, and fit, which is the training step. All of this is going to be on the canvas for you to explore and modify as you need to. There's also another option down here, which is the score tool. And we're going to go ahead and put this onto the canvas. This is the tool that enables you to take a new data set that you want to make predictions on and feed it into this model. So this is ultimately how you can draw insights and make predictions on that new data set. Okay, so let's go ahead and exit to the canvas. Here it is. We've got the input data, we have the assisted modeling tool, and we also have our logistic regression pipeline with each tool configured how we made it in assisted modeling. You can notice here that we have data typing. We have the missing value imputation. What do we do with that data when there's missing values in the column? We've got column selection. Which columns do I want to use when I'm creating that machine learning model? We've got one-hot encoding. This was a step that happened behind the scenes in the assisted modeling experience, but this is enabling us to use categorical variables in our machine learning model in a proper way that the machine learning model can understand. We've got the logistic regression algorithm. This is where you can go in and really fine-tune that algorithm and get information as to what's going on and how that logistic regression is working. Finally, we've got the fit step, which is how we actually train this model. So this was the entire assisted modeling experience. We started with an input data set. We had the assisted modeling tool. We created an assisted modeling pipeline that was output onto the canvas. And now we have a score tool with a hanger that we can put new data into and we make predictions on that data set. So now that was the entire assisted modeling demo for starters, and I want to go one step deeper and really understand what's going on with this model. So I'm going to do a couple things here. I'm going to put a Create Samples tool onto the canvas. I'm going to switch this origin over to estimation. Now let me tell you what I'm doing here. What I have done is I have taken the churn data set. Since we don't have data that we want to draw insights on right now, I'm going to play a trick where I am introducing some of the data to the machine learning model for training, and then I take that other bit of data and I feed it into the score tool to make predictions. So now it has data that it has never seen before. So what I've done is I've split up the data. 30% of it is going to be trained, and 70% of it we're going to use to make predictions. So now I can run this model. Here what's happening, and you can notice it's really fast. We have created this model, we've trained it, and now we're making predictions, and things are just finishing up here, and it's done. So now we can see our data set here. We have a new column now, which is churn predicted. So suppose I want to see how well that did. It turns out I can put a formula tool down. And here I can say, let's create a new column. I'm going to call it count. And here what we want to see is if the churn, which was originally in our data set that we used to train, so we're going to be making a comparison here, is equal to the churn that we predicted, then let's give this new column a 1. Otherwise, let's give it a 0, and that means that it made a mistake. And let's end that statement. And I'm going to go ahead and change this to a double so we can do some math on it. So I'm going to drag this down here, and then in addition, we're going to put a browse tool on here. So let's run this again. Once again, we are starting up that machine learning pipeline. We're introducing data into the score tool, and we're training this logistic regression model up. Now what we can do is we can click on this browse tool and really understand what's going on. So if I go over and I click on count, it might be a little bit small on the screen here, but we can notice that the average here is 0.80, which is 80% for logistic regression. So let's go back in and see if that compares up to how our model was trained. Let's see if we have an overfit model or if we have a model that is really, really well trained and behaving properly. It turns out the logistic regression model was trained with about 80.3% accuracy, which is a really, really good sign, which means assisted modeling did great, and we created a model that is not overfit. Suppose, however, you want to get some more information and figure out how some of these other models are going to do when you're introducing new data and you want to draw insights, maybe with a random forest. Let's go ahead and put that tool down onto the canvas as well. Here, I have two models now side by side, both coming out of the assisted modeling tool. And we can do the exact same thing here. So let's go ahead and go into this tool. We're going to copy, paste. We're going to connect these two up and put the same data that the logistic regression tool had over into the random forest. And if we train these now, we'll be able to see how these two models have done comparatively with the data that we are introducing into assisted modeling in the score tool, and we can also see if random forest has been overfit or if it's a really, really good model. So on the logistic regression, I'm not going to go back in there because it's the exact same thing. We have about 80% accuracy as we saw a moment ago, but if I go over into the random forest, we can see that the accuracy here is about 0.778, which is 77.8%. So let's go ahead and go take a look at that random forest and see how we did compared to when we trained. It turns out here that we did really, really well. The random forest was trained with 76.7% while training, and when we went in and made predictions on new data, it was about 77%. This is a really good sign. This is the assisted modeling experience and how we can enable citizen data scientists and business analysts to go one step further with an educational experience on building a model with machine learning. Melissa, I'm going to hand it back over to you for Q&A.
Thank you so much for that exciting demo, Tyler.